So 4-7 is about a thing called antiderivatives. They are what they would sound like what they would be. It's the opposite of doing derivatives. So instead of me giving you a formula and you doing the derivative's already been done and you're trying to reverse engineer your way back to where it came from. Can anybody tell me where 6x squared could have come from? 2x to the third. So what we're used to doing when we go in a derivative way, we take the power and it goes to the front and it multiplies. So usually we've been going plan 1, multiply. Step 2 is the power goes down 1. If we're going to go in the opposite system, we have to do the opposite stuff, but also do it in the opposite order. So instead of going a finish of power down 1, you have to start with power up 1. Then you take that new power, and instead of multiplying in front, you'll have to divide. So this is out. So plan 1 is now power up 1. Plan 2 is divide out front. So x squared thing becomes x3, with 12 becoming 12 won't be 6. 12 will be 4. We're going to divide the new power. This x goes up to 2 because it was a 1. Out front, 3. The 5 gains an x. If it has a number, it just gains an x.
Is that integration?
Yeah, your spoiler alert here. Chapter 5, come back. Yeah. So this, the 6x squared, third, 2, the 9 thing. Yeah, 9/2 is fine. Simpler, I think. You can go decimal if you want, but I like fractions personally. 4x. A different voice. Somebody other than Micah?
It would be x4.
There's an x4, yeah.
5/4.
Agreed. Pick on you. Yeah. Agreed. Back to you.
Was 9/2 x squared.
Agreed. Agreed. Anybody, anything? Am I still within the boundaries of the screen? Can you tell? Root x? What have we done before about root x?
Put in parentheses with 1/2.
It is x to the half. So same system applies. We just need to take the power up 1. What's up 1 above a half? 3/2. Quickest thing to do there is add the bottom onto the top. Adding 1 is, if you try to do common denominators, you'd have the same bottom with the same top. 1 is 2/2. You don't need to write that out every time. Just add the bottom onto the top and you're good. What happens when you divide that new fraction?
2/3.
It flips to be 2/3. Let's attack this one, same way. What power of x is that thing going to be?
X is 7/3.
Close.
Negative.
Negative, because it's on the bottom, 7/3. For the power, add the bottom onto the top. Act like 7 negative is the top. So add +3 from the bottom onto -7 on the top. -4/3. And then out front, -3/4.
So you always just flip it.
Yep.
Always flip it.
Yeah, when you divide, you flip. Yep. Question about this. all of these answers are incomplete for the same reason. Anybody have a perception on why all of these answers are incomplete, potentially? They might be right, they're probably incomplete answers.
There could be another number.
There could be another number. This could be like +3. How can we check all the answers we just made? By doing the derivative. What would happen if you do the derivative of this? It just disappears. So maybe it was a 3. Or maybe it was a 5. Or maybe it was never even there. There's no way to know. There's no way to know if that number was or wasn't there unless you have more information. That's a job for tomorrow. Tomorrow they'll give you more information. We'll figure out what that number would have, could have been. For now, what we need to do is just write that maybe there is a number there. So we're going to write plus C. There could be a constant added on. No way to know. No way to know if it was there. No way to know what it even was. Okay, so we're just going to go like this, and like this, and like this. And on a test, maybe you want to just go something like this, just to cover your whole page. You could write plus C, plus C, plus C, plus C, plus C all the way down, or I'm comfortable if you want to just write like a plus big, tall C to cover all your bases. Question about that light? Can you turn me slightly and I'll adjust over here to the trig light. So cross the line into trig world. So we're doing our trig derivatives but backwards. So who could we do derivative of and sine would show up before?
Cosine.
Cosine. If cosine was here, did it show you up a positive sign or did it show you up a negative sign? Because we had some of those that were crisscrossing on us.
Negative.
It did make negative, so we'll need to do that. How about cosine? Who used to make cosine?
Is that fine?
That is sine. Did sine make cosine regularly when we did derivatives before? Yeah. So in our past, if the problem had a co, we had to get into negatives. Now that we reversed, if the answer has a co, you've got to get into negatives. So sine is going to become cosine. Since I said co, I've got to go negative. A thought on how to finish this? I'm going to drop you a 4x. Whatever the argument was, it'll never change. But there is a number here. Anybody have a theory on what the number there needs to be? It won't be a 2. Let me back up theory. Okay, how do we say we could check stuff? Do the derivative. If we did the derivative of this, it's which rule? It's the chain rule. We've got to work from outside in. There's like parentheses there that are invisible, but they're there. We work from outside in. Cosine would become sine. Well, who's popping out?
Is it just a 4?
There would be a 4 popping out. We don't want a 4 popping out. So when 4 tries to pop out, it needs to have a nemesis awaiting it to like eliminate it. Who can eliminate the 4 that would pop out? One-fourth. It's a lot like over there where our new power kept showing up on the bottom every time, that other column. Like when we made fifths, there were 5 on the bottom. 4 is on the bottom. Whatever this argument is, it's going to show up on the bottom. So sine 4x is likewise going to make a cosine 4x. We're going to get a negative involved. We want to produce an 8 though.
Oh, would that be 2?
It's going to be a 2. Because the 4, we're going to have to divide by that 4 essentially. Cosine is going to become sine. Argument is 7x. We don't want a number to appear, so we've got to like kill this 7.
1/7.
1/7. this one, cosine becomes sine, 7x, 11 over 7. Sine becomes cosine, negative, x over 2. What's another way we can write this?
1/2 x.
Half x. So who wants to pop out? Half. Don't let it. How do you prevent the half?
2 over 1.
2. Cosine 2 pi x becomes sine 2 pi x. Who would try to pop out at you?
2 pi.
2 pi.
over 2 pi.
1 on top of 2 pi. Let's come up with this. Who did we forget? Maybe number. There's maybe a number, maybe plus 2s and plus 3s and plus whatevers. So if you want to go plus E plus E plus C, be my guest. I tend on my papers to go something like this. It's there. I don't want to write it 20 times. It's just there. That's all I've got. Okay, so antiderivatives, opposite of derivatives. On the ones that have powers, power goes up 1 first, then divide in the front by the new power. On the tricky ones, do the trig transformation, copy the argument, and then divide in the front by what the argument is. I don't remember if this homework has stuff like secant 7x, tangent 7x. In case it does, where did secant tangent come from? Derivative of something used to make those.
Was it cosecant?
What's not?
Secant was a secant x tan x.
Yeah, secant produced secant and tangent in our derivative answers. So we'd want to go in reverse, go from 2 words to 1. Argument 7x, 1 over 7. Secant squared. Who used to produce secant squared when we did the derivative? That was tan. So we'd go here with 5x, 1 over 5. I don't know that they'll stick with just sine and cosine the way I did, but any of those could be in play. If it was cosecant squared, that came from cotan, but we'd have to work a negative into anything that we co. If it were cosecant cotangent, that's caused by cosecant, but anything co, work a negative into it. And if this had tens, we'd go tenths or whatever it would have.
So you always put the negative outside the...
Negative's at the very beginning.
Yeah.
It's usually negative, probably a number that's, eliminating the existence of the chain rule, popping in numbers you didn't want. Question on antiderivatives at all? Homework off of this, it's 262, it's 1 to 16, but it's more than 16, if I remember this right. They go some A's and some B's and some stuff like that. They deceive you with 1 to 16s. Yeah, there's like an ABC section. And they do mix and match all the trig things, so it's good that I mentioned that. Secant tan and secant squared and those things, they are all in there. The first 10 are strictly like the first column of the algebra stuff. The last 6, it's more like tricky stuff, but 1 to 16. Tomorrow, 4-7b, we would take on problems where they'll give you a little bit more info in such a way that you can figure out the C's. So it'll be calculus and then some algebra, because you'll have further algebra knowledge known going in. That's it.